So the first thing is adding and subtracting fractions with a denominator, the same denominator, so 3/8 plus 5/8. When fractions have the same denominator, you always keep the denominator the same. Okay, so you don't change the denominator, you just add the numerator. So I have 3 parts of 8 plus 5 parts of 8. 3 plus 5 would be 8, and then 8 over 8 is just 1. If you're subtracting, you still do it the same way. This is 7/12 minus 4/12. You keep the denominator the same, so it stays as a 12, and I have 7 minus 4. I just do the numerator. 7 minus 4 would be 3. 3 over 12. Alex, when you're dealing with fractions, might tell you, hey, you're right, but you need to reduce it down before just counting it wrong. But anytime you can divide the same number by both of those, you want to do that. So I can divide 3 by 3, and I can divide 12 by 3, so I get 1/4. Okay. The next topic, I'll pause right here. I probably won't write this one down because it says using a calculator to approximate a square root. I guess if you need to see that real quick, you can. I have my calculator right here, but the square root of 20, you would just do 20 and then square root and approximate it, so it'd be 4.47. But that one you just use a calculator for, so that one shouldn't be too bad. The next one is when you have an exponent around a fraction. A exponent means you're taking that times itself that many times. So what I'm actually doing when I do 1/3 is 1/2 times 1/2 times 1/2. Okay, I'm taking 1/2 times itself 3 times. The easy way to do this, though, is to go and take this 3 times everything inside the parentheses. So if I do 1 to the third, not times, I'm sorry, I shouldn't have said times. 1 to the third and 2 to the third. So take that, everything in the parentheses to the power of the third. So 1 times 1 times 1, like if you want to write this out, 1 times 1 times 1 would be 1, and then 2 times 2 times 2 would be 8. Okay. So you can look at it like the red way or the blue way. But the easy way to do that, again, this is going to come in handy later on too, when you have an exponent outside the parentheses, is to take everything inside that to that power. This one is 3/4 squared. So again, what I'm actually doing is 3/4 times 3/4. But I'm going to take this 2, everything to the power of 2 inside there. So I do 3 squared and 4 squared. So 3 squared is 3 times 3, which is 9. And 4 squared is 4 times 4, which is 16. The next topic says find the perimeter of a rectangle with length 6 and width 4. So anytime you have a word problem talking about this, it's nice to draw it out. Sometimes Alex will give that to you. So if my length is 6 and my width is 4, the opposite sides are the same. So like this is the same as this, so that would be 6. And this is the same as this, which would be 4. And then perimeter, remember, is the distance around the shape. So if you walk the perimeter, you're walking around the outside. So what you want to do here is usually you add, okay? So 6 plus 4 plus 6 plus 4 would be 20. I guess I'll show you this just in case. You may see like this formula, because the lengths are the same and the width are the same. So what you actually do is I have 2 6s, so I do 2 times 6, and I have 2 4s, so I do 2 times 4. So you can do it that way as well, but I always just think perimeter, you add them all up, because then that works for every shape. It's always the distance around. Calculate the perimeter of a square with the side length of 5. So if one side is 5, that means all my other sides are 5 as well. Okay. So you can do 5 plus 5 plus 5 plus 5, and it is 20. Or with the square, you can do 4 times the side, which is also 20. Because they're all the same, so I have 4 5, so I can just do 4 times 5. All right, area of a square rectangle. So the first one is area of a rectangle with length 8 and width 3. The area of a rectangle is length times width. These are not formulas you have to remember either. They should give these to you on Alex. I'm sure most of y'all know these, but I'm never going to make you remember a formula either. If there's a formula you need, I usually give it to you. So on this one, we just do 8 times 3, which is 24. And again, the area of a shape is like if you're laying carpet or you're painting or you want to know that. You want to know how much the whole thing is filled in. The area of a square. If the side is 7, the area of a square, you can do length times width because you do 7 times 7, but you can also do side squared because it is the same number all the way across. So 7 squared is 49. Because what's that? Every square is a rectangle, but not every rectangle is a square. You get into those weird logic questions. So you can use length for width on that as well. All right, square root of a perfect square, the square root of 16. This is the opposite of an exponent. This is saying what number 2 times itself is 16. What number 2 times itself is 16? So 4 times 4 would be 16. And then this one, 81, so y'all know that's 9 times 9. So the square and the square root are inverses of each other. Write a one-step expression for a real-world situation. So write an expression for the cost of buying in books at $10 each. So if I am going to buy a $10 book, if I buy 1, it's $10. If I buy 2, it's $20. If I buy 3, it's $30. So I do 10 times in. Okay, they'll tell you which variable to use there. But that is changing based on how many books that I buy or you buy or whatever. Kind of the same thing on the next one. Write an expression for the total distance traveled at 60 miles per hour for T hours. So 60 T. Because if I go 60 miles an hour for 1 hour, I've gone 60 miles. If I go 60 miles an hour for 2 hours, I've gone 120 hours. Okay. So depending on how long I go 60 miles an hour is how far I'm driving. Translating a phrase 5 more than a number x into an expression. So a number x is my x, and I want 5 more than that. So I just add 5 to that. 5 more would be, more than would mean I'm adding to it. So like keywords here, and if I use a color that you can't see, let me know. More than means you're adding. Twice a number y, so we have a number y and we're doing twice that, so we take it 2 times that number because I'm doubling it. Here's a 2-step one. So 3 times number x plus 4. So I have x is my number. You always want to identify your number, what it is first. And I'm doing 3 times that and then plus 4. Got to take those word by word. Write an expression for double a number y minus 7. So I have a number y. I'm doubling that and then minus 7. Next one, evaluate when we're plugging in. So we have the value, or we have the problem 3x plus 5. And we want to know when x equals 2, what do we get? So that here we are plugging the number in. So I plug a 2 in for my x, and then I solve that. 3 times 2 is 6. 6 plus 5 is 11. So when you're evaluating whatever number it's equal to, you plug it into that variable. So on the next one, it's 4y minus 6, and it says y is equal to negative 3. So I plug a negative 3 in for my y. Be careful with your signs here. 4 times negative 3 is negative 12. Negative 12 minus 6. If I owe you $12 and then I borrow 6 more, I owe you 18. On this one, we have x squared plus 2x plus 1, and we want to know when we plug in a 3 what happens. So when I plug in a 3, I get 3 squared plus 2 times 3. So I put a 3 everywhere there's an x. Every x changes to a 3, and then I go through my order of operations. So exponent first, 3 squared is 9, 3 times 3 is 9, 2 times 3 is 6, and then I can add those up and get my answer. Two y squared minus 4, y equals negative 2. All right, so on this one, I'm plugging a negative 2 in for my y. Be careful with your negative here. What you are actually doing is negative 2 times negative 2. So this becomes positive 4. Do not multiply first. You do your exponent first, right? Please excuse my dear Aunt Sally. You do exponent before you multiply. So you do this part first. Negative 2 times negative 2 is positive 4. And then 8 minus 4 is 4. Combining like terms. So on this one, if they share a term, like this 3 has an x with it and this 5 has an x with it. So I put those together. I have 3 of them plus 5 more of them, so I have 8 of them. Oops. Same thing on this one. I have 7 y's plus 2 y's. It doesn't matter that they're not next to each other as long as they're on the same side of the equal sign when we get there. We're not there yet. We'll do that Wednesday. So 7 plus 2 would be 9, and the 4 does not have a y, so I do not put it with it. You can't combine the 9 and the 4 because the 9 has a y and the 4 doesn't. This one's not much different. It just starts throwing in some negatives in there. So I have 4 x's, and I take away 2 of those x's, so I end up with 2 x's. And again, the 2 has an x and the 5 doesn't, so the 5 stays by itself. On this one, again, we're combining our y's, so we have the sign goes with it. Whatever sign is in front of it is the sign for that. So even though we may read this as negative 3y plus 7 minus 5y, that is like a negative 5. So it's negative 3 minus 5, so I have negative 8 y's plus 7. Multiplying, kind of like the exponent, when you have a number outside, instead of taking the exponent to everything inside here, we're going to take this times everything inside of here. So 5 times 3 would be 15x. This one, same thing, but with a negative. Negative 2 times 4y would be negative 8y. I know I'm going through these fast, but I can tell by the look on y'all's faces that... Yeah, that's fine. That's fine. Well, and again, I will upload this too, so you can print it and all that too later if you want to. I think you'll get through these first 2 modules, that Essential Skills and Module 1, pretty quick. But the distributive property, actually, I'm going through all this, so y'all are just going to test out of it, right? So distributive property here, anything or whatever's on the outside, I multiply times everything on the inside. So I take it times x, so 3 times x is 3x, and then 3 times 4 is 12. Take it times everything inside there. And then this one, I take the 6 times everything in there. So 6 times 2y would be 12y. 6 times 1 would be 6. Same thing, but I think we're doing a negative on the front this time. So negative 2 times x would be negative 2x. Negative 2 times 3 would be negative 6. So negative times a positive is negative. Negative 4, 2y minus 5. So negative 4 times 2y would be negative 8y. And negative 4 times negative 5, negative times a negative would be positive 20. All right, here is multiple steps that we may have to do. So again, we want to do the multiplication on outside the parentheses first. So 2 times x is 2x. 2x plus 3 is 6. But I still have this 4x hanging out there. I don't multiply it by 2 because it's not in the parentheses. And now you can combine like terms. These both have an x with it, so that's going to be 6x. And then the other 6 stays by itself because it doesn't have an x. On this one, again, I distribute. 3 times y would be 3y. 3 times negative 2 would be negative 6. And then I just write the 5y down. Then I can combine these. The y's, 3y plus 5y would be 8y. And then the negative 6 stays there because it doesn't have any friends to join up with. Oh, we got some other stuff adding in here. Okay, on this one, you cannot put an x squared and an x together, but you can put 2 x squareds together. So I have 2x squared plus 3x squared would be 5x squared. And then 4x minus 2x would be positive 2x. So you can only combine it if everything after the coefficient, the number in front, if all of the stuff behind that number is the same, you can add it together. All right, so it's a very similar problem. You can put the y squareds together. So 5y plus 3y squared, or 5y squared plus 3y squared would be 8y squared. And then negative 2y plus 7y would be positive 5y. What are we ending with? A couple word problems? No, just one more word problem. Okay. Distinguish between perimeter of a rectangle and area. I mean, we kind of already did both of these, but rectangle with length of 10 and width of 4. So the perimeter of this would be 10 plus 4 plus 10 plus 4, right? Because I got 10 down here and 4 over here. So my perimeter is 28. My area, that's the distance around. My area is going to be 10 times 4, which is 40. Well, how does Grok say this? Perimeter measures the boundary and area measures the enclosed space. One thing to note here, this is centimeters. I didn't do this on the last problem. This is actually centimeters squared. And you may have never had a teacher tell you this. They just know that you do when you do area, you do squared. The reason because when I multiply, I actually multiply the units as well. So this is 10 times 4 is 40. But then you also multiply the units. Centimeters times centimeters would be centimeters squared. The units are also do part of the properties as well. So that is why you do squared when you do area, because you're multiplying them. I think I'll skip that one since we've done perimeter and area a couple times now. Greatest common factor. The greatest common factor is the biggest number, I guess in the way that I'd say it, the biggest number, that's the greatest. Biggest number, you can divide both by, okay? I guess both by evenly, I'll say. Like, you don't get a decimal. The biggest number you can divide both of them by. So this one is 12 and 8. Yeah, 12 and 18. So the biggest number you can divide both of these by, we have the answer right there, is 6. There is a way to do this. I don't really like it because most of y'all can just think about this. The way, two different ways to do it here. This is the way that I do it, is you pick a number to divide it by, okay? 12 and 18, we know we're going to think 6. 12 divided by 6 is 2. 18 divided by 6 is 3. Is there anything else I can divide 2 and 3 by? No. So my answer is 6. Okay. I'll show you what if you pick the wrong number in just a second. The or here, and I got to remember exactly how this works, but we'll figure it out, is if you do the factor tree, 4 times 3, 2 times 2. 12 is 2 times 2 times 3. 18, I think the first thing that might come to mind is like 2 and 9. So 2 times 3 times 3. So what you can do is, this is called the prime factorization. 2 times 2 times 3 is 12. 2 times 3 times 3 is 18. For the greatest common factor, you actually just write what they share. So they share a 2 and they share a 3. So 2 times 3 is 6. You can do it that way. I don't really like doing it that way. I like to just kind of guess and check from here. And I'll show you what happens. I know y'all see the answer right here. But what's the first thing that you think divide 24 and 36 by?
12.
No, the first thing. 6. That's usually the first thing I know. You might think. I know 12 is the right answer. You might think 6. That's fine. Or you might think the right answer first. But if you accidentally divide these by 6 and think that, this is a good way to check it. 4 and 6. Okay, can I divide 4 and 6 by something? I can divide those both by 2. Can I divide 2 and 3 by anything? Nothing besides 1. So my greatest common factor here is 6 times 2, 12. That's why I like doing it that way, because you can just divide it and then see very easily if you can divide it again, then it's both of those, okay? Now, if you see 12 automatically, obviously that's the easiest way to do it, but you can always check it real quick by dividing them out, and then if you can divide those by something, then you can just take the two numbers you divided by and get your answer. Okay.